Thermochemistry. Thermochemistry is the study of energy changes that occur during a chemical reaction. The word thermo means heat. Heat is the energy that transfers from one object to another with different temperatures. Heat always flows from warm to cold. Heat is described in many occasions and equations as Q. The law of conservation of energy is that energy is neither created or destroyed. The energy of the universe is constant. There are two types of heat flow, endo and exothermic. Endothermic is heat being absorbed. Endo means to enter. In endothermic, Q is positive. Exothermic is heat being released. Exo means exit. In exothermic, Q is negative. Specific heat is the amount of heat to raise 1 gram of a substance to 1 degree Celsius. It's unique on a data table. In the equation, C equals J over grams times Celsius, C is the specific heat, J is joules, mass is grams, and temperature is degrees Celsius. In the example, what is the specific heat of aluminum if temperature of a 28.4 gram sample of aluminum is increased by 8.1 degrees Celsius when 207 joules of heat is added? In this equation, you would write C equals 207, because 207 is the joules, over 28.4 times 8.1, because 28.4 is the grams and 8.1 is the temperature. After multiplying 28.4 times 8.1 and dividing 207 times that, you will get C equals 0.899 degrees Celsius as your answer. And that is the specific heat of aluminum. In the equation Q equals mc delta T, or Q equals mcat, is the equation to find the heat of a substance. In the formula, Q equals heat, M equals mass, C equals specific heat, and delta T is the change of temperature. Calorimetry is the measure of heat flow into or out of a system. A calorimeter is a device that measures heat flow. In the example problem, a small paddle is heated and placed in a foam cup containing 25.0 milliliters of water at 25.0 degrees Celsius. The water reaches a maximum temperature of 26.4 degrees Celsius. How many joules of heat are released by the pebble? So you'll start off this equation by writing Q equals mcat, because Q equals mc delta T. So the Q we don't know, so we're trying to find, and the M would be 25.0 grams times 4.184, because that is the specific heat of water, and change in temperature would be 26.4 minus 25.0. So after multiplying this all out, you will get Q as 146.44, and that will be the joules released by the pebble. In the heat of changes in state chart, you start at 0, and you would use MCAT to warm up. And this is because you have a change in temperature. So once you get to 0 degrees Celsius, it'll be melting, so you will not have the change in temperature. It'll just be the mass times the specific heat. So every time you're going up the chart, you're using the change in temperature, but if not, you are using the measurement times the specific heat. So every time you get to a flat point, a melting or vaporize, you will use the numbers given on the right side to add in to use to multiply. So you will see how to use this in the next example. In the example problem, how much heat is needed to change 3.00 times 10 to the second grams of ice at negative 30 degrees Celsius to steam at 130.0 degrees Celsius. So you'll start by using Q equals MCAT and writing 3.00 times 10 to the second times 2.04 joules times 30. So you use the 2.04 joules because that is given to you in this set of numbers for specific heat, and the 30 is because you're starting lower and you're raising up to 0. So you're starting at negative 30 and raising up to 0 degrees. So once you multiply that out, you get 18360 joules. So that'll be the first equation. And the second one, right here on the chart, you're melting. So you'll have the 333.6 joules / grams times the mass. So it'll be times 2. So you get this right here on the equation. Okay, that's not erasing. So then you will continue on to multiply that out and get 1,00080 joules. And then here you get 3 is the third equation, and you're going to be raising up from 0 to 100. So here you'll multiply 3.00 times 10 to the second times 4.184, because that was the because it's water now, times 100, because you're raising up to 100. And then you will get 12.5520 joules. And then the fourth, you'll be going from 100 and just staying on 100, vaporizing. So you get the 2260 from here, and then you multiply that by 6780. Oh, never mind, you don't do that. You multiply it by 3.00 times 10 to the second, and you get 678000. And then the fifth equation, you will multiply 3.00 times 10 to the second times 2.00 times 30. And in doing so, you will get 18000. Now once you get all the equations up to the number you are looking for, which was the 130, you add all of these numbers. You add this, 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 and this. So once you add them all together, you get 939,960 joules, and that would be your answer.